Today I'm going to have a look at flip-flop. Sorry about that, I meant flip-flop circuit. Yeah, it's drawn on AutoCRUD. That's my version of HandCAD, whatever you want to call it. It's a bit rough drawing, but it's a flip-flop circuit that I'm going to have a quick look at and see if I can understand it. So let's have a look. Okay, so here we have my circuit, very crudely drawn. A couple of transistors, a couple of resistors, sorry, a couple of capacitors, some resistors, LEDs, so I can see that it's actually flip-flopping between the two states, turning these two transistors on and off. Now, the way I see it is that these are only here so I can see that it's actually operating. So this point is at effectively supply voltage, 12 volts. So what am I saying there? That is going to be at 12 volts when it's turned on. So is that point there going to be at 12 volts? So the positive side is of these electrolytics are got a positive voltage in comparison to the negative side, which has got a 1 meg ohm resistor, and then they're connected to the transistor. So as we know, when the capacitor is turned on, the capacitor will charge, so the voltage here will rise to the supply voltage. But what's on the other side of that? Because of this 1 meg ohm resistor, well, I suppose that's not too hard to work out, I suppose, is it? Well, I can work out the current. It's a case of what voltage is that going to drop. I don't know, one was thinking, looking at this going, are they in parallel and they're in series? They're in parallel with each other really, but because they're connected to different points, I don't think it's actually going to have an effect of being like two resistors in parallel. Anyway, let's have a look at the current and what else might be going on there. So I've got 12 volts divided by that's 100 ohm, 1000 ohm, it's a 1k, it's a 10k, it's a 100k, that's a 1 meg. We're looking at 12 microamps, but I suppose the current's neither here nor there. It's a case of what voltage is being allowed to be created on this side. It's obviously going to drop a certain voltage, and to me, when I look at it, the transistor has 0.7 of a volt because that's when it needs to turn on. So that's what we're going to get. That's what it's going to need. Regardless of that, that's going to drop basically 11.3 volts or something like that when we first turn this on. I don't know. I suppose I'll have a look at a circuit which I've got here. So let's turn this one on and see if it works. There you go. We've got a flip-flop. The only thing is trying to understand why it's working. So let's get a multimeter. Set it to volts. Now I suppose the first thing I want to look at, if I turn this off a moment, is what will be the voltage on the, at this point here. When I first turn it on, it should go up to 12 volts very quickly. So let's see if I can get the probe on that. And so I can flick this on. Very quickly went up to nearly supply voltage, then obviously it started to flip-flop. And that's moving between a state of about 7.5 volts and 10 or supposedly should be 12 volts, I suppose. So it's up to the supply voltage nearly. Turn that off and find another point to look at. Let me just change this cable because I want a different one so I can more easily connect into the circuit without having to hold the other cable all the time. Okay, so what was I going to look at? I want to look at this point, the other side of that capacitor. Again, just got to get my probe into that, see if I can get it in. I think that's it. It's obviously not discharged, are they? So if I turn that on, that discharge. If I can get that this is not fully discharged, so when I first turn this on, the positive side quickly goes up to 12 volt supply, and with this one we get a minus voltage from 0, or about half a volt, up to about 4 volts, minus 4 volts should I say. What is that in relation to this voltage? When I first turn it on, that goes up to supply voltage. Gonna have to get something to discharge these capacitors. So let's try that again. When I turn it on, it's going to go up to supply voltage, but which one's going to come on first? It seems to be that the green one tries to come on first, or the red one does, and then the green one is the main one. See if that's a case that again, or whether it's just completely random as to which one comes on first. Look at that, provide a little bit of power in there from the multimeter. Yeah, it doesn't seem to matter, does it? Yeah, quick little circuit. Can't quite get my head around it. All I know is that it does work. That works. We have, it comes on and one side, the capacitors will charge, one side will switch on the transistor. That transistor is going to discharge and that voltage is going to drop, but it doesn't drop all the way. It only drops to about 7 volts, and then when that has discharged enough, it would appear that this transistor turns off because of that capacitor. It's discharging through. See what I mean? Which one's doing what? That's why I have trouble understanding this. All I know is that circuit works. I know it works because I've got a circuit working there, and this is sort of understandable in that these two capacitors will charge up because of the supply voltage, even though we do have a small voltage here which actually should be just enough voltage to turn the transistor on, which is usually about 0.7 of a volt supplied there, or like a biasing to help keep it on, or to provide some voltage. But when either one, like this one, turns on, that will discharge. With discharging this capacitor, the LED will be on, but at the same time we've still got a small voltage here which is turning this one on, so that's discharging, that one's charged up. This is helping to bring this voltage up, I presume, which will then turn this one on. That will start discharging. But when it does that, this transistor has now effectively turned itself off, or that voltage is now low enough. See what I mean? Tell you what, if you've got any comments about this, have an understanding about the actual mechanics or electronics of this circuit, then put it in the comments, because I know it works, I can make it work, but I don't fully understand why it works. I'll have to spend some more time looking at it, I think. So there you go, it's a flip-flop. It's a basic flip-flop circuit and it works. I can change these resistors as well, these resistors here, make them smaller so it oscillates much quicker, or I could put even bigger resistors in here and make it oscillate, flip-flop much slower. I could even put some pots in there so I can change the timing, so one will be on quickly and the other one will be on for a long time or whatever. But yeah, it's a simple circuit, but seems to take a bit of understanding. So there we go, flip-flop circuit. Flip-flop circuit. Don't really quite understand why it works. I know it does. I've got it on the breadboard, it's flashing away. I sort of understand some of the concepts and what's going on, but I don't fully understand why it works. I know that some are turning on and off. But anyway, if anybody can explain that to me, please, in the comments. I'd love to have comments on understanding exactly how this flip-flop works. So, please, get commenting. Anyway, if you like this video, give me a thumbs up, subscribe, and I'll catch you next time.